Good morning, students. Electrostatics. Next point, redistribution of charges. Now, what is redistribution of charges? See, yes, if I have one sphere of radius r1, another sphere of radius r2. Okay, charge on this sphere is q1. Potential is V1, okay, and its energy is, suppose it is U1. Clear? Its capacitance is C1. So yes, for this second charge is Q2, potential is V2, potential energy is U2, and capacitance is C2. Simple? Yes. Okay, charge Q1, here I can write Q1 is equal to, it is C1 V1. Here I can write Q2 is equal to, it is C2 V2. Simple? Now that they are connected, let two spheres are connected. Two spheres are connected by conducting wire. By conducting wire. Let two spheres are connected by conducting wire. Okay. Then what happens? Yes. If these two spheres are connected by conducting wire. Conducting wire. Okay. Then let capacitance remains the same. It is C1 and here it is C2. Okay. Charge on first capacitor is Q1 dash. Charge on second capacitor is Q2 dash. As they are connected, their potential becomes same. Potential becomes same. Potential becomes same. Okay. So yes, its potential is V, its potential is also V. So what is charge on this first capacitor? Q1 dash is equal to, here is C1V, and here is Q2 dash is equal to, it is C2V. That is after connection. This potential V on two sphere is potential after connection. Before connection it is V1 and V2. Clear about this? So now which equations you have to remember? Equations you have to remember, they are, okay, charges on capacitor. Charges on capacitor after connection. Charges on capacitor after connection. Q1 dash, what is charge on first capacitor? Q1 dash is equal to, it is Q C1 upon, it is Q R1 upon R1 plus R2, and Q2 dash is equal to, Q2 dash is equal to, it is Q R2 upon R1 plus R2. Okay, so these are two equations of charge on these two conductors. Q1 dash is equal to Q R1 upon R1 plus R2. Q dash is equal to Q R2 upon R1 plus R2. Where what is Q? Where Q is equal to Q1 plus Q2 is equal to Q1 dash plus Q2 dash. That is total initial charge. That is total initial charge. Simple? So yes, these two equations you have to remember. Okay. Next is, see, after connection their potential becomes the same. So what is common potential? What is common potential after connection? What is common potential after connection? Common potential, V common. Yes, I will write common potential as V common is equal to, as they are connected, common potential is total charge upon total capacitance. C is equal to Q upon V, so V is equal to, it is Q upon C. Total charge upon total capacitance means it is Q1 plus Q2 upon it is C1 plus C2. Simple. Now what is Q1? It is C1 V1 plus it is C2 V2 upon here it is C1 plus C2. So it is really common. It is really common. So yes, you have to remember this equation special. Okay, what is common? If two capacitors are connected, then what is common potential? C1 V1 plus C2 V2 upon C1 plus C2, where C1 capacitance, V1 is potential of first capacitor before connection. V2 is potential of second capacitor before connection. So yes, you have to remember this equation. And now we will see one question. Based on such distribution of charges. Okay, see what is question. Yes, you are given a 2 microfarad capacitor which is charged as shown in figure. The percentage of its stored energy dissipated after the switch is turned to position 2. See what is question actually. You are given two capacitors, 2 microfarad and here is 8 microfarad. Okay, yes. It is voltage V. It is voltage V. Okay, this switch is initially in this condition. So it is open. So you have to find if the switch is turned to position 2, what is percentage change in energy? Percentage of its energy stored as dissipated means percentage of changing energy. So yes, first case 1, when switch is in position 1, when switch is in position 1. So when switch is in position 1, figure is like this. Okay, here it is V and here it is 2 microfarad. Okay, simple, because as there is no connection, it is called open circuit. So we do not have to consider this. We have to consider only this circuit. Simple. So what is total initial energy? This initial energy Ui is equal to, it is half C square. C means it is 2. Half C V square means here it is V square. So 2 cut. So Ui is equal to, here it is V square. Ui is equal to, here it is V square. Initial energy is V square. Simple. Now case 2. Okay, when switch is turned to position 2, in this switch is turned to this position, then what happens? See, this switch 2 is then turned to position 2. It is 2 microfarad, it is 8 microfarad. Okay, now as this switch is turned to position 2, it is disconnected. This battery is disconnected and these two capacitors now they are connected. So yes, it is like this. Okay, two capacitors they are connected. So first of all, I will find what is their common potential. Yes or no? Yes, I will find what is their common potential. So common potential V common is equal to, what is equation? Yes, equation is C1 V1 plus C2 V2 upon C1 plus C2. C1 2. Initially this capacitor is charged by this V. Initially this capacitor C1 is charged by V. So it is 2V plus C2, that is A, 0. Because it is not connected in circuit. So what is potential difference between two ends of a microfarad capacitor? 0. Divided by this 2 plus 8 it is 10. 2 divided by 10 it is 1 by 5. So common potential is V by 5. Simple. So yes, here what is common potential? It is V by 5. Yes, we have common potential. V common is equal to V by 5. Now, what is final energy? Yes, final energy UF is equal to, it is half C equivalent. These two capacitors they are in parallel connection. Yes, these two capacitors, they are in parallel connection. So what happens? Yes, their equivalent capacitance is their equivalent capacitance, which is 8 plus 2. It is 8 plus 2. And what is V? Common potential is V by 5. So it is 4 square. Simple. After the relation, what is total capacitance? It is C1 plus C2. 8 plus 2, V by 5 whole square. So is equal to, it is 1 by 2. 8 plus 2, it is 10. It is V square divided by 5 into 5. Okay, so it is 5 into 2 and it is 10. So this is square by 5. So what is percentage change in energy? Percentage change in energy. Percentage change in energy, it is UI minus UF upon UI into 100 is equal to, what is UI? Yes, UI is V square minus, what is UF? It is V square by 5. Okay, and divided by UI means it is V square into 100. So is equal to V square minus V square by 4. It is 4 V square by 5. Yes or no? So it is 4 by 5 V square upon V square into 100. So V square cut 5 into 20. So it is 80%. It is 80%. Simple. So yes, it is one question which is based on connection of two capacitors. Okay. Now next question. See, a parallel plate air capacitor has capacitance C. When it is half filled with a dielectric of dielectric constant 5, percentage increase in its capacitance is 400%, 6.56 and 33.3 and that 200. See, case 1, what is given? Case 1 means initial condition. Case 1, a parallel plate air capacitor, suppose it is like this, a parallel plate air capacitor, medium between two plates is air. Let cross sectional area is A of this plate. This cross sectional area is A. Distance between two plates is D. Yes, it is simple. Then in this case, what is capacitance? C is equal to, it is epsilon 0 A upon D. Now, when it is half filled with a dielectric constant 5, so see case 2. It is case 2. And yes, it is half filled like this. It is half filled like this. Yes, it is half filled like this. Then your question is, what is, yes, you are doing this filter, don't worry. Okay, yes, then your question is, what is capacitance, what is percentage increase in capacitance? So yes, that is C1 is equal to epsilon 0 A upon D. Now in this case, what is C2? Yes, what is C2? Yes, as we have two different medium means there are two capacitors. Means there are two capacitors. First this one and second this one. And yes, these both capacitors, they are in parallel connection. But if in this region it is N, in this region it is another medium having dielectric constant 5. Okay, as there is parallel connection, you know what is equation for parallel connection? C1 plus C2. Okay, for this capacitor, see, this total cross sectional area is A. This distance is D. This total cross sectional area is A. So half filled means it will be A by 2. And also for this capacitor it will be A by 2. Then how to write C2? C2 is equal to, how to write C2? C2 is equal to, it is for air part epsilon 0 A by 2. What is distance between two plates? It is D. Plus for this lower one, epsilon 0 K. Why epsilon 0 K? Because another dielectric medium is used. Cross sectional area A by 2. And separation, here it is D. Simple? Yes, it is simple. Then C2 is equal to this epsilon 0 A divided by 2D common. Here it will be 1 plus this K. What is value of K? It is 5. 8K is 5. So 5 plus 1 is 6 and 6 divided by 2 is 3. So it is 3 epsilon 0 A divided by 3 epsilon 0 A divided by D. Now you have to find what is percentage increase. So percentage increase is equal to C2 minus C1 upon C1 into 100. See, it is nothing but I can write it is 3C1 epsilon 0 A upon D is equal to, it is C1, so 3 epsilon 0 upon D is 3C1. So is equal to, it is 3C1 minus C1 upon C1 into 100. 3C1 minus C1, 2C1. 2C1 upon C1, so it is 2 into 100, which is 200 percentage. It is 200 percentage. Clear? So yes, one easy question. Okay, how to find equivalent capacitance and what is percentage increase in capacitance. Now next question, see, you are given one figure. Two capacitors are there having capacitance 2 microfarad and 3 microfarad. Yes, it is point A, it is point B. Okay, two batteries having voltage 6 volt and 16 volt. You have to find what is potential difference between A and B. What is potential difference between A and B? See, first of all, we will eliminate some answers. You have to find potential difference between A and B, means VA minus VB. VA minus VB. Yes. Okay. Two answers are positive and two answers are negative. See, 16 volt. It is 6 volt. 16 volt, 6 volt means you are given two batteries. So first of all, we will find what is resultant potential difference. What is resultant potential difference? Okay, what is resultant voltage? And I can draw one figure like this. If I can draw one figure like this, see, 2 microfarad capacitor, 3 microfarad capacitor, and only one battery. Only one. Now, why I am drawing only one battery? It is 16 volt and it is 6 volt. They are in series connection in opposing condition. Two cells are connected in series opposing condition. They are connected in opposing condition. So therefore, resultant voltage V is equal to resultant voltage. V is equal to, it is, I can write it 16 minus 6 is equal to, it is 10 volt. Why minus? Because they are in opposing condition. Opposing condition means minus plus, plus minus. They are in opposing condition. Okay, that we have discussed in chapter number 3. So yes, I can replace these two cells by only one cell having voltage V is equal to, it is 10 volt. V is equal to, it is 10 volt. Okay, it is capacitance having 2 microfarad and it is capacitor having 3 microfarad. It is A and it is B. It is A and it is B. Yes, two capacitors, 2 microfarad and 3 microfarad, they are in series connection. Okay, 2 microfarad, 3 microfarad, they are in series connection. So what is the equivalent capacitance? It is 2 into 3 upon 2 plus 3. So it is 6 divided by 5 microfarad. It is 6 divided by 5 microfarad. Simple? Yes, it is simple. Okay, 6 divided by 5. Clear? Now, it is equivalent capacitance connected to V is equal to 10 volt. So what is charge? What is charge? Total charge. Okay, what is total charge? Q is equal to, what is equivalent capacitance? Yes, equivalent capacitance is 6 by 5 into, what is voltage? Q is equal to C, so it is 10. So it is 5. Here it is into 2. So it is 6 into 2, which is 12 microcoulomb. It is 12 microcoulomb. Clear about this? What is charge? What is charge? Total charge. Or we can say these two capacitors are connected in series. So charge on each capacitor. For series connection. For series connection. Charge on each capacitor. Charge on each capacitor. Q is equal to, it is 12 microcoulomb. Okay, so on this capacitor charge is 12 microcoulomb, on this capacitor charge is 12 microcoulomb. Now we have to find potential difference. So therefore, potential difference between two ends of A and B, or between two ends A and B is equal to, it is Q. What is charge? It is 12. And what is C? Its capacitance. Sorry, you have to find potential difference. So V is equal to, it is Q upon C. V is equal to, it is Q upon C. What is Q? It is 12. And what is its C capacitance? That is 6. That is 2. That is 2. So 12 divided by 2, it is 12 divided by 2, 12. It is microcoulomb. 2, it is microfarad. So 12 divided by 2, it is 6 watt. But I will write minus. Why minus? Why minus? See, A and B, this battery and this battery, EMF or voltage of this battery is greater than this battery. Okay, so if it is positive terminal, potential of B will be positive, potential of B will be positive, and potential of A will be negative. Also, according to this figure, as it is positive plate, this B will have positive potential and A will have negative potential. So VA minus VB, obviously it will be negative. VA minus VB, it will be negative. So yes, your answer is negative. So yes, your answer is negative. Clear about this? Right. Now next question, C. Two condensers of capacity 2C and C are joined in parallel and charged up to V. The battery is removed and the condenser of capacity C is filled with dielectric having dielectric constant K. Then the potential across the capacitors now. See, first of all, I will draw case 1. What is case 1? First figure, first condition. Okay. Two condensers of capacity 2C and C are connected in parallel and charged up to. Here let C1 is equal to 2C and C2 is equal to C are charged up to voltage V. Simple? Yes. As these two are in parallel connection, potential difference is same. So before connection, if charge on first capacitor is Q1 is equal to it is C1 V is equal to it is 2C V. Charge on second capacitor Q2 C2V. It is 2. Sorry, C2 means it is only C. So it is C. Simple. Now the battery is removed and the condenser of capacity C is filled with dielectric having dielectric constantly. Means case 2. See, battery is removed. Okay. Here it is C1 is equal to 2C and capacity C is filled with dielectric constant. It is filled with dielectric constant, having dielectric constant K. Then yes, in this situation what happens? Yes, in this situation, this C2 is equal to, remember, when air is completely replaced by another dielectric medium, its initial capacitance was C2 is equal to C. That it is C1 dash, it is 2P dash, it is KC. Why KC? Yes, you remember, okay, if it is replaced by, air is replaced by another dielectric medium, it is KC. Now, let, in this situation, common potential is V dash. Let common potential is V dash, because as they are connected, their common potential is V dash. Charge on first capacitor Q dash, Q1 dash. Q1 dash is equal to it is C1 dash V dash. Simple. So yes, is equal to it is, what is C1 dash? It is 2C V dash. Charge on second capacitor Q2 it is V2 dash V dash. C2 it is KC V dash. Now yes, capacitance changes, voltage changes, but law of conservation of charge, according to law of conservation of charge, total initial charge, that is Q1 plus Q2, is equal to total final charge, that is Q1 dash plus Q2 dash. Okay, what is Q1 plus Q2? It is 2CV plus CV. What is V1 dash? It is 2CV dash plus, here it is KCV dash. Simple. So it is 2CV plus CV, 3CV. Here it is V dash, yes, CV dash common. CV dash common means it is 2 plus K. So C cut, so V dash is equal to, it is 3, sorry, yes, it is 3V upon 2. It is 3V upon 2. And yes, 3V upon K plus 2. It is your answer. Clear? So yes, there are some questions based on capacitor. Now again in next lecture we will see some questions based on capacitor. But for today, this is it.